Hello, can you hear me?
Yes.
Okay, so questions from yesterday. This was the first one, right?
Right. I think it's 6 tan x plus 1.
Uh, Answer is 6. How did you do that? I hope you have not differentiated and done it. Did you
I
differentiate?
did differentiate. Yeah.
Okay, that is one way. If you cannot think of it in the exam, then you should differentiate and get the answer. But otherwise, if you want to do it properly, how would you do? So this one becomes tan x minus 1 by tan x plus 1, right?
Right.
3 times. And 1 by cos square x is sec square x. So you can say that tan x is equal to t is a good substitution, right? So it will become integral is 3 times t minus 1 dt by t plus 1 into t cube plus t square plus t, right?
Right.
Okay. Now here this part we have to think about. So if I divide it by t square, what will happen? If I divide by t square, I have to multiply a t here, right? So
Right.
what I'm saying is t outside and inside would be t plus 1 by t, right?
Yeah.
Correct. And here it is t plus 1 and up it is t minus 1 on top, right? So I want to take this as my z. If I need to take this as my z, I need 1 minus 1 by t square dt, right? As dz,
Right.
correct? And on top I have t minus 1, so I have to divide on top by um, on top I can divide by t. If I divide by t, I get 1 minus 1 by t. So I have to divide by t square, I think, right? If I divide by t square, I get 1 by t minus 1 by t square. I need a 1 minus 1 by t square on top. So that is what I have to think of. So okay. Minus 1. Okay, so I need a t square minus 1 by t square term, dt, right? So this is what I need on top. So I can just say this is t minus 1 into t plus 1 by t square. I've just multiplied it there. And I have to multiply here also, then down t plus 1 by t square. And there is a t down already, right? You understand what I'm saying? I need that term on top, right?
Right.
So I have just multiplied it by whatever it takes to get that term. And in the denominator also I have multiplied it by that, right?
Yes.
And here there is already t plus 1 and t. So the whole thing becomes, this top part will become your dz. And here you'll have t plus 1 whole square by t, which is t square plus 2t plus 1 by t, right? And root over z, right? Z is t plus 1 by t, right?
Right.
So this part is t plus 1 by t plus 2, which is equal to z plus 1, right? This.
Right.
So finally, you are getting z plus 1 into, okay, I think I realize what I have done wrong. I should have taken this as z square. So I would have gotten 2z dz on top, right? Everything is same, I think, except 2z dz is on top, right?
Yes.
If I take this as z square, then I will remove the root also in this step, right? So I will get integral of z plus 1 into z, and on top I'll get 2z dz, right?
Z square plus 1.
Z square plus 1, right? This is, yeah, z square plus 1 into z, correct. And you get 2 tan inverse z, right?
Right.
And 2 into 3 becomes 6 tan inverse z. And t plus 1 by t becomes this. Correct?
Yes.
In the exam, it's fine to differentiate. So the second one you got the answer. It was like this: x power 26, x minus 1 power 17, 5x minus 3 dx is equal to x power 27, x minus 1 power 18 by k plus c. You have to find k.
9.
9. Yeah, 9 is correct.
Differentiated again.
Okay. Uh, that's fine. In this question, I think differentiation is much faster than any other option. Otherwise, you'll have to do integration by parts here. You'll have to choose the correct terms to integrate and stuff. It Like you can split it and try integration by parts, right? It will become 5x power 27, x minus 1 power 17, minus 3x power 26, x minus 1 power 17, right? Correct.
Yeah.
And try these separately by integration by parts, but it will be quite long. So it is better to differentiate here. The next one was fx is equal to integral of 0 to x ln 1 plus t square dt. And you have to find out f double dash 0. Right?
It's 0.
It is 0. How have you done? F dash x was what for you?
I did by parts and then differentiated it. So
So first you integrated it. So you can take x outside, right? It's a constant, right?
okay, right.
Could have taken x outside because it's not a variable here, no?
Right.
I hope you did that because otherwise it will not make sense. Correct, no? Did you do it as t and then by, how have you done it? This is not t.
No, I didn't. I think I did something wrong. Yeah. I didn't take it as constant.
So if there are two variables in an integration sign, then only the sign that is the variable that matches with the dt will be the variable, no? Right?
Right.
So you are supposed to do it like this. Fx, you can write it as x into integral of 0 to x ln of 1 plus t square dt. And then you don't need to integrate it. You can directly differentiate it. Differentiate it by what method? By product rule, right?
Right.
Because you realize that this expression will come out as something in terms of x because of this x here, right?
Yeah.
So by product rule, if I differentiate, it will be differentiation of x, which is 1 integral 0 to x ln 1 plus t square dt plus x into differentiation of this What would be differentiation under integration sign for this? X
ln
into
1 plus x squared.
ln of 1 plus x square into 1 minus 0, right?
Right.
So this is your f dash x. And now second step, double derivative is easy because it's all a function of x now. Here it will be again ln of 1 plus x square plus here again by product rule 1 into ln 1 plus x square plus x into 1 by 1 plus x square into 2x, right?
Right.
Now when you have to find f double dash 0, you just put the values. This is 0, this 0, and this is 0, right?
Right.
So the question is actually just about being able to differentiate properly. Like this x has to be taken out and then you have to do product rule, right?
Yeah.
The next one was that inverse question. So question was f of x is equal to x cube plus x plus 1. G of x is the inverse of f. And equation of tangent to y is equal to g of x at x is equal to 3, you have to find.
Y minus 1 is 1 by 4 into x minus 3.
1 second. Y minus 1 is 1 by 4 into x minus 3. Yeah, correct. How? How do you find the tangent? You have to find derivative of g dash 3 you have to find, right?
Right.
To find slope of the tangent, right?
Yeah.
What is g dash 3?
1 by 4. Okay, the
How do you
equation.
get it?
Yeah, so x is f inverse x cubed plus f inverse x plus 1. Then you differentiate that
X is
at x.
what?
If you put f inverse x in f of f inverse x in that equation and then differentiate it, you'll get 1 is 3 times f inverse x squared plus into f dash inverse x plus f derivative of f inverse x.
What is the rule that you're using to find this? What is the method here to find inverse of derivative of inverse? Or what is the first thing that you do?
Okay, you put in the equation of f of x, I put x as f inverse x. And then I differentiated
Why?
that equation.
Why
And
do you use x as f inverse x in this equation?
like
Why? What is the reason?
is equal to x because you want to find the derivative of f inverse x at 3. So
But
you
how
can
can
just
you?
differentiate.
But how are you putting x as f inverse x? What is the logic? Why are you putting x as f inverse x?
Because I want an equation in f inverse x in terms of x.
If you want an equation in f inverse x, then you cannot just start by replacing random things as f inverse x. No, like because you want f inverse x doesn't mean you do whatever you want, right?
Okay.
Oh, explain why you can put x as f inverse x and why will this work? What is the reason?
X. I mean, x is it can be anything, right? So
X can be anything, so you have replaced x with f inverse x. Oh,
like
because you are saying the other side is f of f inverse x is equal to x.
yeah.
Okay, fine, that is correct. If you replace the function with x with f inverse x, you get this then.
Okay, then you differentiate that And
3 f inverse x into f inverse x's derivative whole square plus f inverse x's derivative is equal to 1. So then
yeah, and in the previous equation, you can put x as 3 to get f inverse 3 will be 1.
f inverse 3 x as 3 you will put in this.
Yeah, in both of them, if you put x as 3.
F inverse 3 is what?
F inverse 3 whole cube plus f inverse 3 plus 1 plus 3.
That's
So that
fine.
means,
This equation is coming, but you have to know the value of f inverse 3, right?
yeah, so for that, you can use the previous equation.
Which
This,
equation? This.
yeah, the one below that.
So what is f inverse 3?
F inverse 3 is 1
Why? Why is f inverse 3
because
1?
if you put 3, then you'll get f inverse 3 into f inverse 3 whole square plus 1 is 2. And 2 can be factored only as 2 into 1. So f inverse 3 has to be 1.
I mean, you have done it correctly, but the ways you are doing it is very weird. So this is how I do it. I mean, you are using the equations in very awkward ways. I don't know how you have learned it, but so I want to find out slope, right? Slope of g. Gx is f inverse x, right?
Okay.
I want to find g dash x. So obviously here finding the inverse is impossible. Like you cannot solve for y in terms of x. You cannot do x in terms of y, right?
Okay.
So what you have to do is use either this f of g of x should be x or g of f of x should be x, right? Because they are inverse of each other, correct? If you use this equation and differentiate this, you will get f dash g of x into g dash x is equal to 1, right? So g dash x would be equal to 1 by f dash g of x, right?
Okay.
This is fine.
Yeah.
This is coming from here directly. So what is g dash 3? G dash 3 is 1 by f dash g of 3, right?
Yeah.
Now what is g of 3? We have to find out g of 3. Let's say g of 3 is y. Then what does it mean? It means that 3 comma y is a point on g of x, right?
Okay.
Correct?
Yes.
And you know that whenever you have a inverse, the graph of an inverse is a reflection on y is equal to x line of the function, right?
Okay.
So when you do a reflection on y is equal to x line, what happens is x comma y becomes y comma x, right?
Okay.
So if 3 comma y is a point on g of x, y comma 3 is a point on f of x, right?
Yes.
This is the same thing as saying that if f inverse 3 is y, then obviously f of y is 3, right?
Okay.
Correct. So what is the value of y that makes 3 here? What is y so that 3 is equal to x cube plus x plus 1? It is obvious that x must be 1, right?
Yeah.
So this f of 1 is 3. So we know the value of g of 3. G of 3 is 1 then, right?
Yes.
So this equation is what? 1 by f dash 1.
Yes.
f of x is known, so f dash x is simple. F dash x is 3x square plus 1, and f dash 1 is 3 plus 1. So 1 by f dash 1 is 1 by 4. You understand what we are doing? We are
I
not
think I did the
putting,
same thing, but
but don't
yeah.
put it in the equation and do some many steps and all. Like, I don't know how you are doing it in by putting it in this equation and all. You can just directly write it like this. No, this is something that you should use, right?
Okay, yes.
And then put 3 here, and then you'll get g of 3. You have to figure out that is 1 and f dash 1. So you get this 1 by 4. If you get after that, writing the equation of tangent is easy, right?
Yes.
Okay. Then the next one is this one. Area bounded by the curve. Area bounded by the curve y is equal to x square minus 1 by square plus 1, and the line y is equal to 1 is what? You need to understand the graph of this roughly. to be able to figure this out, you can write this as x square plus 1 minus 2, right?
Right.
It will be 1 minus 2 by x square plus 1, right?
Yeah.
And that means that the graph of this is always below 1, right? What is the minimum possible value that y can take? X can be 0, right?
Right.
Then 1 minus 2, it will be minus 1, right?
Yes.
And after that, other points, you will see that it will rise up. And this is, let's say, plus 1. Y is equal to 1 is this line. Correct? So when x is 1, you will realize that this will be 1 minus 1, 0, right?
Right.
And after that, as x becomes very large, it will be something like this. X becomes very large, then you have something approaching 1, right?
Yeah.
And you can see that this is clearly an even function. So the other side would be exactly replica of this, right?
Yeah.
Right. So the area that is bounded by the graph here and the line is all of this area, the whole area, right? So what is the integral that you should write then?
Minus 2 by x squared plus 1.
What?
1 second.
1 minus this, right?
Yeah.
So 1 minus 1, so 2 by x square plus 1, right? And the limits of the integration are technically from minus infinity to infinity, but you can say double of 0 to infinity, right?
Yeah.
Because the area this side would be same as the area this side, right?
Right.
So this is just 2 tan inverse x evaluated from 0 to infinity, that is pi, and 2 pi is the answer, right?
Right.
What were you doing before I told this? You were drawing the graph. Generally, in area questions, it is a good idea to draw the graph. Correct? Because if
Yeah.
you don't draw the graph, you will find it difficult to understand, first of all, which function should you subtract, y1 minus y2 or what, and what are the limits and all, right? Here we are subtracting 1 minus this function and evaluating the integral over the entire region, right?
Right.
Okay. Next one is the general solution. The general solution of the differential equation. The differential equation is 1 plus tan y dx minus dy plus 2x dy is equal to 0 is what? You have to find the general solution for this differential equation. What are you trying? You should split everything. Minus 1 plus tan y dy plus 2x dy is equal to 0. And take all the dy's on this side. So you'll have 1 plus tan y dx is equal to 1 plus tan y dy plus 2x dy, right?
Okay.
If you divide by 1 plus tan y, you get dx is equal to dy plus 2x by 1 plus tan y dy dy. And bring the dy this side, you get dx by dy is equal to 1 plus 2x by 1 plus tan y, right?
Okay.
Wait, I made some sign mistake. This is minus 2x and it goes to the other side, right? So this is minus. So what you get is dx by dy plus 2x by 1 plus tan y is equal to 1. Or you would get some other version if you had done dy by dx, but something like this you should have gotten, right? How do you solve this integral? This is linear first order differential equation. The method to solve this is using the integrating factor method. You know that technique, right?
Yes.
So in the integrating factor method, it used to be like this: di by dx plus px into y is equal to qx. And the answer used to be y into if is equal to integral of q into if, right? Where if is equal to integral of if is e power integral of px dx, right?
Okay.
In this case, x and y have been interchanged. So your answer will be x into if would be equal to integral of q into if, where if would be integral in terms of y, right? Q into if would be e power integral of p of y dy, right?
Okay.
P of y is my 2 by 1 plus tan y, right? So e power integral 2 by 1 plus tan y dy is this, and q is 1 and x is here. So x into if is equal to integral of whatever is the if integral, right? Because q is 1, right?
Okay.
So you have to find out this integral, find this integral. Integral of 2 by 1 plus tan y is sin y plus cos y. And on top you have a cos y, right? So top part cos y can be written as cos y plus sin y plus cos y minus sin y, and divided by this can be written as 1 plus cos y minus sin y by cos y plus sin y, right?
Okay.
And notice that this integral of this is equal to this, a differentiation of this, right? Denominator. Minus sin plus cos is the differentiation of the denominator, right?
Okay.
So your integral of the overall thing is simply y plus ln sin y plus cos y, right? Right.
Yeah.
That is your e power y plus ln sin y plus cos y is your integrating factor. Correct?
Yes.
So now we say x into if is equal to integral of if. So x into e power uh, y plus ln sin y plus cos y is equal to integral of e power y plus ln sin y plus cos y dy. Right? So this is just e power y multiplied by sin y plus cos y, because ln will become this, right? And here you have integral of e power y into sin y plus cos y dy, right?
Yes.
Okay, so this is your solution. You will add a plus c to the solution. Now you have to simplify this e power y sin y plus cos y dy.
E power y sin y.
Huh? This can be done by parts a little bit, I think.
It's
Or
e
you can
power.
separate it out, right? Separately do e power y sin y plus e power y cos y, right? These are both doable integrals.
Yeah, the differentiation of sin y is cos y. So it's that formula.
Oh, fx
E
plus
power
f dash x. Yeah, yeah, yeah.
yeah.
It is e power fx. Yeah, yeah. E power x fx plus f dash x it is, because fx is sin x, right? So the answer here will simply be e power y sin y, right? And here it is e power y sin y plus cos y. So you will divide everything, and or you can keep this as your answer. This is your answer, because now we have removed all the integral signs, right?
Right.
Okay, so this was this method of linear first order differential equations, the integrating factor method. Now the next one is this one. You have to solve the differential equation y square dx plus x square minus xy plus y square dy is equal to 0. How are you? Are you getting something?
Yeah, x5. You put x5 as t. Homogeneous.
This is homogeneous one. So eventually you should get it, right? Dy by dx you should isolate and then put x by y as t or y by x as t, whatever. Right?
Right.
Nothing very difficult here. Eventually you'll get the answer. Then okay, we have this one. If f of x is equal to x cube minus 3x plus 1, the minimum number of real roots of f of x is equal to 0. You have to find. In order to understand this, first try to plot the graph of f of x. F dash x is equal to 3x squared minus 3. 3 times x minus 1, x plus 1. And critical points are x is equal to plus minus 1. F double dash x is equal to 6x. So at x is equal to 1, double derivative is positive. So that is a minima, right? And at minus 1, double derivative is negative. So it's a maximum. So minus 1, 1. There is a maxima here. Value of f of x at minus 1 is minus 1 plus 3 plus 1. So plus 3, right?
Right.
And value at 1 is 1 plus 1 minus 3. So minus 1. Something like this. That value at 0 is 1, right? This is 3. And this is minus 1, right? And we know that it is a maxima here. So the curve must be like this. And it's a minima here. So curve must be like this, right? Okay, so then curve is like this, then it will cut like this here, and it will cut like this here, right?
Right.
Correct. So there are 3 roots for f of x is equal to 0 as 3 roots, correct? Right.
Yes.
Now let's check the value. Like we know that one of the roots is below minus 1 and one of the roots is above 1, right?
Right.
And the other root is between 0 to 1, right?
Yes.
Let's check the values of f of minus 2. That comes out to be minus 8 plus 6 plus 1. So it is negative, right? F of minus 2 is already negative. right?
Right.
So that means the root is somewhere between -1 and -2, right? This root x1, right?
Yes.
And this root is somewhere here, x2, and this root, let's check the values of f of 2. F of 2 is 8 minus 6 plus 1. So it is positive. So that means 2 is somewhere here. So this root is between 1 and 2, right?
Right.
Correct. So now we know enough about this f of x that we can start thinking about what happens when this has to be 0, right? f of x has to be 0. So that means f of x can take only 3 possible values, right? x1, x2, and x3, right?
Right.
You understand? Because otherwise f of x is 0 only at 3 real values, right?
Yes.
So f of x must be x1, x2, or x3 here, right?
Yes.
So now let's think about x1. F of x can be x1. How many ways can this happen? Now x1 is a value between, x1 lies between -1 and -2, right? Correct.
Right.
So think about the function behavior in -1 and -2. Function behavior is, it is strictly, if you look from this side, it is strictly increasing, right?
Yes.
It reaches maxima here, but function is strictly increasing in this range -1 to -2, right?
Yes.
So if it has to equal, if it has to become equal to x1, which is value between -1 and -2, it can only cut that level once, right?
Right.
Are you understanding what I'm saying?
Yes.
Sure, no? It is an increasing function in this region, so it can only cut that level only once, right? -1 and -2. So one solution here, right?
Yes.
Correct. And if f of x has to be equal to x2, x2 was between 0 to 1, right? Something between 0 to 1. So this level, right? This level. 1 is here, some line between 0 to 1, right?
Right.
So that can be intersected at 3 places, right? Are you understanding what I'm saying?
Yes.
fx is equal to x2. x2 value lies between 0 to 1, and a horizontal line here cuts f of x 3 times, no, between 0 to 1. 3 solutions possible here, right?
Right.
And f of x is equal to x3. x3 is between 1 and 2, right? Between 1 and 2. So above 1 and lower than 2, right? So again, 3 lines will cut, 3 solutions, no?
Right.
Are you understanding why only one solution for this case? Because it is below -1. No, -1 was the minima here. So only one line can cut, right?
Yes.
And here also 3 solutions can happen. So the total number of real solutions is 1 plus 3 plus 3, 7. Are you understanding what is happening? First, we figured out the graph of f of x and figured out when does f of x become 0, right?
Right.
Once you got the graph we got by doing maxima minima, finding some values at 0, 1, -1 and stuff. Once we got the graph, we found out the roots, and we found out that the roots lie between -1 and -2, between 0 and 1, and between 1 and 2, right?
Yes.
F of x is 0 means f of x inside our input must be equal to one of those roots, right? So the equations that have to be satisfied is f of x is equal to x1 or x2 or x3. And then we are saying ki x1 value is below -1, so it is below the minimum here. So when f of x is equal to some constant, it will cut only once in this region, and other twos will cut 3 times, right?
Right.
So that is how you figure out the number of real solutions possible for this. We'll continue from this point in the next class. More questions for, we'll almost done with calculus. We'll move on to other topics also soon. So see you in next class.
Okay. Thank you.
Bye.